We use AI pretty much every single day now, right? But for most of us, it kind of feels like pure magic trapped inside a black box. Well, today, we're cracking that box wide open. Welcome to this explainer. We're going to take a guided chronological factory tour of exactly what happens inside the inner workings of ChatGPT. We'll literally demystify the entire process, from the exact millisecond you type a prompt all the way to the second you get your final answer.
Let's start with a scenario you're probably super familiar with. You type a sentence, maybe it's a question, a coding prompt, or just a silly joke, into ChatGPT. You hit enter, and then, just a few seconds later, this incredibly coherent answer pops up on your screen. But what actually happens between those two moments? Like, if we could slow down time to the millisecond and walk through the digital assembly line, what exactly would we see? Well, that is the exact mystery we're solving today.
To understand this, we first have to jump our biggest hurdle, the language barrier. On one side, we have your view as the user. When you type a question, you're thinking in human concepts, emotions, complete ideas. But on the flip side, we have the machine's view. And here's the thing. A computer doesn't speak English or Spanish or French. It speaks math. It only processes numerical data. So the absolute first step on our factory tour has to be translation. The system has to convert your human sentence into something it can actually calculate. Which brings us to step one of our journey, breaking it all down into what we call tokens.
So, what exactly is a token? Simply put, it's the basic, fundamental piece of text that a language model processes. See, when you feed a sentence into the AI, it doesn't just swallow it whole, it chops it up. And why does this matter? Because these tokens are the absolute raw material of artificial intelligence. Now, it's super important to know that a token isn't always a complete, neat little word. Sometimes a single longer word might get sliced into 2 or 3 different tokens. Or a token might literally just be a comma or a question mark. These little chunks are the actual units the machine is going to be working with.
Now, how can we visualize this? Well, a really great analogy is to think of your entire typed sentence as a finished Lego structure, like a toy castle. For the AI to do anything with it, it first has to break that castle down into individual Lego bricks. Those individual bricks, those are the tokens. But we do need to separate this helpful analogy from the actual mathematical reality. Because in reality, once your sentence is broken down into those literal text bricks, they are instantly converted into complex numerical representations. The computer isn't looking at the word apple, it's looking at a long string of numbers that represents that token in its vast mathematical space. Okay, so we've got our numbers. What's next? That leads us to part 2, understanding context and the magic of the transformer.
This brings us to a genuinely revolutionary concept in modern AI. What is it? It's called the self-attention mechanism, and it's a core feature of what we call transformer architectures. So why does this matter? Well, without it, words are just isolated little islands. Think about it. If you just have the word bank, does it mean a river bank or a financial bank? You need context. The self-attention mechanism allows the model to look at all the other tokens in your prompt and mathematically calculate the relationships between them. It basically weighs how much attention each token should pay to every single other token so it can figure out the true meaning of the sentence.
So, how do we visualize this attention? Well, think about how you read a really dense paragraph. You'll often find yourself pausing and darting your eyes back to important words earlier in the sentence, right? You naturally weigh the surrounding context to figure out what a specific word means. But for the machine, the reality is obviously a bit different. It doesn't have eyes or a memory in the human sense. Instead, it figures out these contextual relationships based on billions of parameters it learned during its massive training phase. It runs a staggeringly complex mathematical equation to decide exactly which numerical tokens heavily influence each other. All right, we've broken the text down and we've mapped out the context. Now for the really exciting part, predicting the next word.
This is where the model actually generates its answer, and it does it through this mesmerizing, nonstop repetitive cycle. Step 1, it takes in the current context. That's your prompt plus whatever it's already written. Step 2, based on all those learned mathematical patterns we just talked about, it estimates the probabilities for what the very next single token should be. Step 3, it selects one token. And finally, step 4, it repeats the entire process. It takes that brand new token, tacks it onto the context, and starts all over again to predict the next one. It's just a continuous looping generation cycle, building your answer piece by piece, token by token, accumulating text until the entire response is completely finished. Now, this brings up an absolutely crucial point, and we really need to bust a super common myth here.
A lot of people think ChatGPT is basically just a giant fancy search engine. The misconception is that it looks up your question in some massive hidden database, finds a pre-written answer, and just copies and pastes it for you. But no, absolutely not. The reality is that the model is generating entirely new text on the fly. It is predicting continuations based purely on the patterns and relationships it learned during training. It's literally constructing a unique response from scratch right before your eyes. Which naturally leads us to a really big question. Is all of this actual intelligence or just a really good illusion? The reason it feels so incredibly smart lies in the sheer mind-boggling scale of what it's learned. It comes across as intelligent because it's absorbed extremely complex patterns in human language. It successfully uses context, it accurately recognizes deep relationships between abstract concepts, it predicts highly logical sequences, and it can even perform learned patterns of reasoning and problem solving. But, and this is so important to remember, there is no tiny, conscious person sitting inside the computer thinking up these answers. It is, at the end of the day, a staggeringly complex calculator performing mathematical probability at a scale that simply mimics intelligence. And because it's running on probability rather than absolute hard truth, we occasionally get this really weird phenomenon known as an AI hallucination. This happens when the model spits out an incorrect response that somehow sounds incredibly, perfectly convincing. Why does it do that? Well, remember, it isn't retrieving verified facts from a database, it's just predicting what words logically follow each other based on its training patterns. And sometimes those patterns point to a string of words that sounds completely natural, but is factually entirely wrong. This is your vital, everyday reminder of why you absolutely must always verify important information with reliable, real-world sources. So, let's pull all of this together and look at the complete cycle in action. Imagine hitting that Enter key. At exactly 0 seconds, your user question is submitted as text. Almost instantly, like by 0.1 seconds, that text is shattered into numerical tokens. By half a second, the transformer architecture is running its self-attention mechanism, weighing the context of every single token against all the others. By 1 second, it's making its very first next token prediction. And then, from second 1 to second 3, it is locked into that high-speed repetitive loop, predicting token after token after token, until finally, the completed, readable response is sitting right there on your screen. It's obviously an unbelievably complex internal mechanism. But if we want to distill the absolute core reality of this system into one overarching idea, it is simply this. You provide the context, the model processes the mathematical patterns, it predicts what comes next, and it repeats that process to construct a response. That is the true, demystified reality of the AI we use every single day. Which leaves us with this final, kind of provocative thought. We've seen today that ChatGPT isn't a thinking brain. It's a giant pattern-matching predictor. But if an AI can generate essays, write code, and hold these seemingly deep philosophical conversations just by predicting the next piece of a puzzle based on learned patterns, well, what does that say about how much of our own human communication is just following predictable patterns? I'll leave you to chew on that one. Thank you so much for joining me on this explainer, and keep exploring.